Recommended wiring methods for low voltage lighting include firstly, Class 2 or Class 3 cable, specifically designed for low voltage lighting systems, typically rated for 300 volts or less, available in stranded conductors which are suitable for crimping and code compliant for use in low volt lighting applications. Secondly, flexible non-metallic conduit, often referred to as flex conduit, provides physical protection for the wire, can be used with stranded or solid conductors, is easy to route and install, and is code compliant when used with appropriate connectors and fittings. Thirdly, Romex, specifically NMB cable, with stranded conductors, is a common type of residential electrical cable, available with stranded conductors which are suitable for crimping, may not be specifically rated for low voltage lighting, but can be acceptable in certain situations, so checking with the local electrical inspector for specific requirements is important. It is important to follow the manufacturer's instructions for the specific lighting system being used and always consult with the local electrical inspector for final approval of the wiring method. Given the use of crimped ends, stranded conductors are necessary. Therefore, the best options are 1. Class 2 or Class 3 cable, the ideal solution, specifically designed for low volt lighting and allows for crimping. And 2. Romex with stranded conductors. If Class 2 or Class 3 cable is not available, Romex with stranded conductors may be acceptable. However, it is essential to check with the electrical inspector for approval. Additional tips include using a separate circuit for low volt lighting, installing a transformer rated for the total wattage of the lighting system, using proper connectors and fittings to ensure secure and code compliant installation, and testing the system thoroughly before energizing it. The 2008 National Electrical Code, or NEC, and local amendments govern the installation of electrical systems, including low-voltage lighting. It's crucial to adhere to these codes to ensure safety and compliance. Article 411 specifically addresses low-voltage lighting and power systems. This article covers systems operating at 30 volts or less. It provides guidelines on wiring methods, transformers, and overcurrent protection. Chapter 3 of the NEC covers wiring methods and materials. While Romex, or NMB cable, is a common wiring method for residential applications, its suitability for low-voltage lighting depends on several factors. Firstly, the NEC requires that all wiring methods be suitable for the voltage and environment in which they are installed. While Romex is typically rated for 600 volts, its insulation may not be suitable for direct, burial, or wet locations, which are sometimes encountered in low-voltage lighting installations. Secondly, Romex typically contains solid conductors, which may not be compatible with crimp-on connectors used in some low-voltage lighting systems. As the inspector noted, stranded conductors are generally preferred for crimping because they provide a more reliable and secure connection. Class 2 and Class 3 cables are specifically designed for low-voltage lighting and signal circuits. These cables are typically rated for 300 volts or less and are available with stranded conductors. They are also designed to be more flexible and easier to work with than Romex, making them a good choice for low-voltage lighting installations. Flexible metal conduit, or FMC, and liquid-tight flexible metal conduit, or LFMC, are also acceptable wiring methods for low-voltage lighting. These conduits provide physical protection for the wiring and can be used in both dry and wet locations. When using conduit, it is important to ensure that the conductors are properly sized for the load and that the conduit is properly grounded. Transformers are an essential component of low-voltage lighting systems. These devices step down the voltage from the main power supply to the required low voltage level. Transformers must be sized appropriately for the load and must be protected by overcurrent devices, such as fuses or circuit breakers. The NEC provides specific requirements for the installation of transformers in Article 450. Overcurrent protection is required for all electrical circuits, including low voltage lighting circuits. Overcurrent devices, such as fuses and circuit breakers, protect the wiring from overheating and potentially causing a fire. The size of the overcurrent device must be appropriate for the ampacity of the wiring. The NEC provides tables that specify the ampacity of different types of conductors in Article 240. Grounding is an important safety measure that helps to prevent electrical shock. All metal parts of the low-voltage lighting system, including the transformer enclosure and the lighting fixtures, must be properly grounded. The NEC provides specific requirements for grounding in Article 250. In addition to the NEC, local codes and regulations may also apply to low-voltage lighting installations. It is important to check with the local electrical inspector to ensure that the installation meets all applicable requirements. The inspector is the final authority on whether an installation is code compliant. Consulting with the inspector before starting the installation can help to avoid costly rework later on. Regarding the specific situation with the Lucifer's system, where crimped ends are used, stranded conductors are indeed necessary. In this case, using Romex with solid conductors is not an option. The two best options are Class 2 or Class 3 cable with stranded conductors, as these cables are specifically designed for low-voltage lighting and are available with stranded conductors that are compatible with crimp-on connectors. Romex with stranded conductors is acceptable, but only if Class 2 or Class 3 cable is not available. However, it is crucial to check with the electrical inspector for approval before using Romex with stranded conductors. The inspector may have concerns about the suitability of Romex for low-voltage lighting, even if it has stranded conductors. Some additional tips for installing low-voltage lighting systems include using a separate circuit for low-voltage lighting. This will help to prevent overloading the circuit and ensure that the lighting system operates properly. Install a transformer rated for the total wattage of the lighting system. The transformer should be sized to handle the maximum load of the lighting system. Use proper connectors and fittings to ensure secure and code-compliant installation. All connectors and fittings should be listed for use with the type of wiring being used. Test the system thoroughly before energizing it. This will help to identify any problems with the installation before it is put into service. When working with electrical systems, always follow safe work practices. These include wearing appropriate personal protective equipment, such as safety glasses and gloves, and energizing the circuit before working on it. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. They have the knowledge and experience to install low-voltage lighting systems safely and correctly. In summary, the best wiring method for low-voltage lighting depends on the specific application and the requirements of the local electrical code. However, Class 2 or Class 3 cable with stranded conductors is generally the preferred option for systems that use crimp-on connectors. If Romex with stranded conductors is used, it is essential to check with the electrical inspector for approval. Always follow safe work practices when working with electrical systems.